say Lucas with a K. Okay, before radians is very new to us. We're going to need to start thinking in radians, and today I'm going to go through that. But before I do, when someone came in this morning, I had a thought, and I want to go through it with you as far as rotation diagrams and reference angles. There's 3 real types of rotations you need to be familiar with. And the first of those is degrees, which I'm not at all worried about. So when we do a rotation diagram in degrees, this is 0 degrees. We rotate around to 90 degrees, then to 180, and then to 270, and then back to 360. And we're just climbing at increments of 90. Right? We're good at that. If I ask you to draw a rotational diagram of some measure that's in degrees, I feel good about it. Okay? If I ask you to do it for angles in radians, there's actually 2 different ways that we can be given radians. There's radians in terms of pi, which if this is 0 and we open up this way, what's this in terms of pi? 1 pi, right? Not 1, because 1 would look like 1 radian, but 1 pi. And then we go the full circle, and this would be 2 pi. Okay? So let's quickly talk about these halfway points. If this is 0 pi and this is 1 pi, what's halfway there? It's halfway between 0 pi and 1 pi. A half a pi, right? Which is most traditionally written as pi over 2. And then if we keep going, what is halfway between 1 pi and 2 pi? What's halfway between 1 and 2? 1.5 pi. But you're not going to see 1.5 pi. You're going to see it written as a fraction, 3 pi over 2. 3 halves is the same thing as 1.5. So that's the most traditional way you'll see your radians when they're done in terms of pi. And then we have radians when they're done in terms of decimals. Like if I just said, plot 2 radians, where would that be? Well, in terms of regular numbers, that's 0 radians. How many is this? 3.14, exactly. So you could do this on your calculator if and when you forget this, and you probably will forget it, which is fine. But what is halfway between 0 and 3.14? 1.57. So this really climbs at increments of 1.57, because that's like 1.57 radians is equivalent to about 90 degrees. And then you go 1.57 more, and then you go 1.57 more, which brings you to 4.71. And then why are you guys better than this at this than I am? Oh, good. You're so smart. I love it. 6.28. This definitely comes up the least, I would say. But when it does, I don't want you to panic and not know what to do with it. So there's 2 different ways to express radians. Radians in terms of pi and radians in terms of decimals. Okie-doke? Lucky for us, you should all be very familiar with the fact that pi is 3.14, so we're good with that. Okay. So there are 2, 3, 4, 6. There are 4 main families of radian measures that we're going to have to be familiar with. There's a pi over 3 family, a pi over 4 family, a pi over 6 family, and a pi over 2 family. And each family has a first quadrant version of a family member, a second quadrant version of a pi over 3 family member, a third quadrant version, and a fourth quadrant version. That's the way I'll start. Okay? So in the pi over 3 family, we all know this is pi, correct? Here's 0, here's pi, right? But we want to talk about the pi over 3 family. So what is this equivalent to? Pi is equivalent to how many pi's over 3? 3 pi over 3. Can we all agree that pi and 3 pi over 3 are the same thing. But when I'm dealing with the pi over 3 family, I'm going to think of this as 3 pi over 3. And then I'll have my handy dandy little paper clip, which literally just slipped down into a crack. Of course it did. It's my favorite tool I've ever had. Oh, I got it. If I'm splitting up pi into 3 parts, this half circle is a rotation of pi. I'm splitting that into 3 parts. There's the first pi over 3. And there's the second pi over 3. And there's the third pi over 3. Does everyone see my 3 kind of wedges? Here's my first one that brings me to 1 pi over 3. Here's my second one that brings me to 2 pi over 3. And here's my third one that brings me to 3 pi over 3. Do you follow? And if this is 3 pi over 3, if I went the rest of the half circle, how many pi's over 3 would this be? Say it again. 6 pi over 3. Doesn't 6 pi over 3 reduce to 2 pi? Right? So you're just really getting your denominator to kind of jive with the denominator of whatever family you're working in. So we've got 0 pi over 3, 1 pi over 3, 2 pi over 3, 3 pi over 3. We're going to come down here, and it's actually going to be opposite. This one will be a 4 pi over 3. And then this one will be a 5 pi over 3. And then that'll bring us back to a 6 pi over 3. So if you want to do this to kind of show your wedges, this vertical line is the only thing that gives you a little bit of an optical illusion. Even though that y-axis cuts through that, that's still one full piece. And there you have it. So each pi is split into 3 parts, which means a full revolution of 2 pi is split into 6 parts. So your first quadrant family member is pi over 3. Your second quadrant family member is the 2 pi over 3 angle. Your third quadrant is a 4 pi over 3 angle, and your fourth quadrant is a 5 pi over 3 angle. And guess what? Each one of those angles all has the same reference angle. How far is this from the x-axis? How far is pi over 3 from 0? Well, no, don't go degrees on me. We're thinking in radians right now. If you took the difference between pi over 3 and 0, what's the difference? Pi over 3, right? Here, what's the difference between a 2 pi over 3 and the closest x-axis, 3 pi over 3? Right, from 2 pi over 3 to 3 pi over 3 is a reference angle of pi over 3 also. From this angle, the closest x-axis is also here. What's the difference between a 3 pi over 3 and a 4 pi over 3? Pi over 3. And then from 5 pi over 3 to 6 pi over 3, the reference angle is also a pi over 3. So these are all 4 different angles, but they're all in the pi over 3 family, and therefore they all have a pi over 3 reference angle. Do you follow that? Okay, let's look at pi over 4. If my denominator is 4, this pi is actually going to be labeled 4 pi over 4. See, the other one had a denominator of 3, so we called it 3 pi over 3. This one is a denominator of 4, so we're calling it 4 pi over 4. So we're going to have a 1 pi over 4, a 2 pi over 4, and what does 2 pi over 4 reduce to? That's able to be simplified, right? And so it should make sense that that jives with pi over 2, because that's where we know pi over 2 is. And then we have a 3 pi over 4, and then we have a 4 pi over 4. And then we'll have a 5 pi over 4, a 6 pi over 4. Now the 6 pi over 4 reduces to a 3 pi over 2, which makes sense. A 7 pi over 4, and then 8 pi over 4, which jives with 2 pi. Yes? So, yet again, each quadrant has its own pi over 4 family member. The first quadrant is pi over 4. The second quadrant is 3 pi over 4. 2 pi over 4 is not in this family. And the reason is because that can be simplified. That is technically in the pi over 2 family because that can be reduced to pi over 2. So it's once it's reduced, look at your denominator and see which family it is in. This 5 pi over 4 is the third quadrant version, and this 7 pi over 4 is the fourth quadrant version. And again, if we looked at the reference angle for all 4 of those, they all have the same reference angle of pi over 4. Yes? Okay? Just out of curiosity, how many degrees is pi over 3? Don't do any translations. Think about this. Pi is how many degrees? 180, and you're splitting it into 3 parts. 60 degrees. Pi over 3 is equivalent to 60 degrees. So all of these have a reference angle of 60 degrees in the pi over 3 case. In B, pi is 180, and we're splitting. Do you see the 4 parts that we split this one up into? Here's the first, here's the second, here's the third, and here's the fourth. If you split 180 degrees into 4 parts, how many degrees is each one? 45. So pi over 4 family is like the 45 degree family. Okay? Because pi is just 180 at the end of the day. That's another way, by the way, of translating radians into degrees. It doesn't work unless your radians are given to you in terms of pi, but pi is 180 degrees. You can take out the pi, replace it with 180 degrees, and then you can just do the division or do the math around it. So pi over 6, I'm splitting pi into 6 parts. So this pi, how should I label that, Vince? 6 pi over 6. So I'm going to split this half circle into 6 parts. 3 in the first quadrant, 3 in the second. So this will be 1 pi over 6, 2 pi over 6, 3 pi over 6. 4 pi over 6, 5 pi over 6, and 6 pi over 6. I'm only doing these shadings. You'll probably never do these in all of your life, but just to visually highlight the 6 parts that just got split into. Good? And then the rest of the full circle, Jack, what would I label this as? If this is 6 pi over 6, the rest of the full circle would bring us to 12 pi over 6. Very good. So I need 6 more parts. So I'm going to have, after 6 pi over 6 comes 7 pi over 6, then comes 8 pi over 6, and then comes 9 pi over 6, 10 pi over 6, 11 pi over 6, and 12 pi over 6. Now, I told you that in each family, and right now we're talking about the pi over 6 family, each quadrant has one angle. This doesn't appear that way. It seems like it's got a lot more, yes? But which one of these is not technically in the pi over 6 family? Three pi over 6 is not technically in that family, correct? Because that reduces to pi over 2. So that's in the pi over 2 family. Which one of these also reduces? 2 pi over 6. That's not in the pi over 6 family either, because that would reduce down to a pi over 3. So that 2 pi over 6 angle actually coincides with the pi over 3. So that's actually in the pi over 3 family. Do you follow? So the only one that's in this family is pi over 6. What's our second quadrant one that's in this family? 5 pi over 6. Good, Chloe. Because the other one reduces. 2 pi over 3. So that's not technically in this family. And then what's our third quadrant one, Lucas B? 7 pi over 6. And our fourth quadrant one, Corey? 11 pi over 6. Now, because those are all in the family, those all have a reference of pi over 6, right? The difference between 5 pi over 6 and 6 pi over 6, 1 pi over 6. The difference between 7 pi over 6 and 6 pi over 6, 1 pi over 6. The difference between 11 pi over 6 and 12 pi over 6, 1 pi over 6. You follow? Okay? And then pi over 2. Oh, wait, let's back up. If you split 180 degrees into 6 parts, what is that the equivalent of? 30 degrees. Good. So, not that we're doing this right now, but that's 30 degrees. This is 30 degrees shy of 180, which would be what? If this is 180 degrees and this is 30 degrees prior, 150. This one's 30 degrees after 180, which is what? 210. And this is 30 degrees prior to 360, which would be what? 30 degrees prior to 360. 330, very good. So, without doing conversions the way I taught you yesterday, logically you can wrap your head around the fact that that would be 30, that would be 150, 210, and 330. Good? The last one, pi over 2. If I'm labeling this pi, and I'm talking about the pi over 2 family, this is 2 pi over 2. And so this one doesn't really seem to get cut up at all because this is really our parent kind of looking graph. 0. If this is 2 pi over 2, then this is 1 pi over 2. 2 pi over 2. Down here is 3 pi over 2. And a full circle is 4 pi over 2. And pi over 2 is equivalent to how many degrees? 90. Good. Good, good, good. Any questions? Okay. So the entire back is, oh boy, 16 examples of plot the angle and tell me the reference. Okay? And most of them are in radians in terms of pi until you get down to the very end. So, here's how we're going to do these. Your denominator is 4. So, this is 0 pi over 4. This is 4 pi over 4. And 0 is also going to be labeled, what? What did you say? 8 pi over 4. Very good, Owen. So, if you're going around the circle, which quadrant would 7 pi over 4 fall in? Fourth, yes? So 0 pi, 2 pi, 4 pi, 6 pi, 7 pi over 4 would be there. So for your rotation diagram, show which way you're going. And then how far away is that from the closest x-axis? 1 pi over 4. 7 pi over 4 to 8 pi over 4 is a reference angle of pi over 4. If it starts in radians, give the reference angle in radians. Good question. If it starts in degrees, give the reference angle in degrees. Stay consistent with whichever unit they're in. Okay, for 3 pi over 2, this is 0. This is 2 pi over 2. And 0 also is 4 pi over 2. So, Eric, where would 3 pi over 2 land you? Say it again. In the middle of 90? Like right here? Not quite. Someone help him out. Who can help him out? Haley? It would be this one. It is in the middle, but if you're going around, there's 0, there's 1 pi over 2, 2 pi over 2, 3 pi over 2 is going to land you right there. Does that make sense? But the reference angle is pi over 2. Because how far away is this from the closest x-axis? And you've got two of them that's equally as close to both. So 2 pi over 2 to 3 pi over 2 is 1 pi over 2. Or if you go this way from 3 pi over 2 to 4 pi over 2, that's still a 1 pi over 2 reference angle. Good? Yeah. Right, that's, you would say, right, it's right on the y-axis. You could call it, we use the vocab word quadrantal. That doesn't really come up much. I don't think I've ever seen that on the regions. But yeah, you would say between 3 and 4 would be perfectly fine. Okay? In C, we have a negative angle, so we're actually going backwards. So we're in the pi over 3 family. I'm going to label this negative 3 pi over 3. So if I'm opening up backwards, which quadrant is negative 4 pi over 3 going to be in? Take a second. Think about your answer. Tess, which quadrant do you think that'll land you in? This one down here? Think about this. There's 0 pi over 3. There's negative 1 pi over 3. Then I'm rotating negative 2 pi over 3. And then I'm going to continue to rotate to negative 3 pi over 3. And then negative 4 pi over 3 is actually going to be in quadrant 2. Think about that because you're going backwards because of the negative angle. And then what's the reference? How far away from the x-axis is that, Jack Taylor? Pi over 3. Very good. Have you noticed a shortcut for the reference angle yet? Elena, with a nod, what is the shortcut? Right, whatever family you're in. Exactly. This is the pi over 4 family. Your reference angle pi over 4. Pi over 2 family, pi over 2, pi over 3 family, pi over 3. This one will be a pi over 6. This one will not be a pi over 3. Why not? Chris? It can be reduced. So this one reduces to negative 2 pi, which is a full circle backwards. So it actually, the terminal ray is right on the x-axis. So what is the reference angle? How far away is this from the x-axis? 0. So your reference angle equals 0. So anything that can be reduced, you can't really follow that rule. But anytime it's reduced and the denominator is 2, 3, 4, or 6, you can do that. So all of these, 2, 6, pi over 4. This one reduces to, oh, and what's 15 pi divided by 3? What does that reduce to? Right, just 5 pi. So one full circle is 2 pi. Another full circle brings you to 4 pi. And then 5 pi is going to land you right there, also on the x-axis, but the other side. What's the reference angle there? 0. Again, it's 0 from. What's the reference angle on J? Look at it quickly. You don't really need to think about where it lands. You can just look at it and know what the reference angle is. Pi over 2. How about K? Where's the reference angle? Pi over 6. What? No. So your homework is all those problems that are on this sheet. I gave you the stuff on the back, those little diagrams, for any time you have to draw something out. So they're not actual problems, like they're not numbered on the back, Jason. Do you see them? Are you good? Were you looking at your notes?
Yeah.